If you look at the PV diagram of an isothermal curve, you will see that it is kind of like this. And if you look at the PV diagram of an adiabatic curve, you will see that it is like this. Notice the difference? Well, of course you do. It is clear that an adiabatic curve is much steeper than an isothermal curve. But why is it like that? Well, today we are here to learn why an adiabatic curve is steeper than an isothermal curve. Well, let's get into the mathematics, shall we? Well, the easiest way to prove that an adiabatic curve is steeper than an isothermal curve, we have to establish a relationship between their gradients, right? So we are here to prove that the gradient of an adiabatic curve is something multiplied to that of an isothermal curve. So first, let's deal with an isothermal curve. Well, for an isothermal curve, we again remind ourselves that an isothermal curve kind of looks like this. So we can say that over here, the gradient is basically what? dV of P, since the y-axis represents the pressure and x-axis represents the volume. So in an isothermal curve, we know that the product of pressure times volume is what? A constant K, right? And if we differentiate this with respect to volume V, we have that dV of PV is equal to 0, since K is constant. We can pull this P out and we can say that this is dV of V plus V times dV of P. We have just used the chain rule of differentiation over here. And we have that P times 1 plus V dV of P is equal to 0. We are looking for this over here, which is basically what? This in our expression. And we can use this to get this dV of P. And we have that dV of P is equal to minus P over V. And here we go. We have the gradient of an isothermal curve. Moving on to the slope of an adiabatic curve. Let's look at the curve of an adiabatic process again. The shape of an adiabatic curve is kind of like this, right? Well, then again over here, we can say that the gradient is represented by dV of P, right? So we have to calculate dV of P from our mathematics and intuitions, right? Now, in an adiabatic process, we know that PV to the gamma is equal to a constant K, right? And over here, if we differentiate both sides with dV, we have that is equal to 0, right? Then again, we pull this P out over here, and then we pull this V to the gamma out over here, and we have 0. All right, moving on, we have that P V to the gamma minus 1 times gamma over here plus V to the gamma dV of P is equal to 0. We have to calculate this value of dV of P in order to get the slope, right? So we have that gamma P V to the gamma minus 1 is equal to minus dV of P divided by V to the gamma. All right. And if we do further calculations, we have that dV of P is equal to minus gamma P V to the gamma minus 1 over V to the gamma. And if we pull this gamma out over in the numerator, we have that minus gamma P V to the gamma minus 1 minus gamma And this is basically gamma P over V. And here you go. This is the slope of an adiabatic curve. And if we compare this with the slope of an isothermal curve over here, we have that the slope of an adiabatic curve is, and for an isothermal curve, this is. So it is clear that the adiabatic curve is gamma times steeper than an isothermal curve. Well, that's all.